Okay, oops. Can you hear me? Yes, you can hear me. Okay, well, sorry, I actually do need this screen. I'm having a little bit of vision problems, but I didn't realize I'm going to be doing this sometime. So apologies to that, folks. So hi everyone. First of all, thank you to Amir and to the organizers for letting me take a few minutes of your time on the last day of a very productive week and at this open QSE event. So I was asked to talk a little bit about the considerations as we're continuing to design for the HPC, for the quantum HPC ecosystem that we're building up, some considerations, some things to think about. So I know that we've all been diving in very deep, going technical details on the different work groups. We've been doing that on a weekly, bi-weekly basis for months now, talking about the details, the components, all of this. So zooming in is what's going to get us there. But I'd like to do kind of a bit of a zoom in, zoom out perspective and kind of bring together some things and some realizations and some observations just from this week alone. This has been, I think, kind of a banner week in quantum right now. Not only do we have the QCuff happening and openQSE, we have happening right now is the quantum PI, the Oscar PI meeting happening in Maryland. I just came back from that. Also in our computing ecosystem writ large, as you know, we have the Genesis Summit that just happened a couple of days ago. In Chicago, there's a huge global quantum summit happening. I mean, there's a lot happening. And just because of some of the events this week, I've kind of modified my talk and pulled some things in because I just wanted for us to think about this in the broader scope of what we're working on. So the first big thing, if you haven't heard about this yet, we have a new document in our trove of national assets. This is the blueprint for DOE's quantum supercomputing. This came out this week, finally got launched. A committee that I was privileged to work on. We had been working on this for about 9 months in total. And so this has finally come to bear. And so I have the QR code there. You can also go to the OSTI site and find it. But this is really a culmination of several representatives from the national labs who came together really with the premise of how we're going to be thinking about quantum computing in the next couple of years. So I'll give you a little bit of a quick overview about it. I'll let you read it and all. I just kind of did a very, very simplistic breakdown to kind of orient you. But in this blueprint, we talk about a few things. The first is as a trigger, is a threshold to bring a at least 100 logical qubit system running 10 to the 4 to 10 to the 5 hard logical operations by 2028. So I know some of you are gasping, some of you are like, okay, so that's kind of the threshold mark. That's the target that we're building and that we're thinking about or thinking towards. Not only was the idea of having this system, then what can we do with it? How can we ensure that we have some early success on the system, that we show that we're on a viable path forward on a roadmap as we continue, as the technology matures, as we get increasing qubit counts, fidelities, et cetera. So the second major component is to build the competencies around that system and around that threshold. This is early fault tolerant systems to build up the programming expertise, to build up the early system software environment that's going to need to execute, the compilation tool chains, looking at the standardization, the benchmarks, all those sort of components to basically execute that system and to get it to operate on a target application. And then the idea from there, kind of the third pillar is what I'm calling the breakthrough, that really we're able to utilize it to achieve some new science that we haven't before. So that's kind of a quick overview. And as you can kind of see, there's this roadmap of the projection of the qubits, the logical qubits as we go on into time into the mid 30s. So if you read the section, I can't remember what section is, section 3 or section 4, it goes deep into what science can be achieved in that. So the top part is the delivery target of at least 100 logical qubits, and then looking at the particular applications. And this is not from the document, this is from me and Claude having a chat. This is some of the applications that were mentioned and what the thresholds would need to be in order for the folks on the committee to feel comfortable, realizing that we have a useful result from it. So as you can kind of see, chemistry embedding fragmented portions of workflows embedded into quantum. This is kind of the area that was mentioned in the document as being a likely success in the 2028 timeframe. I won't go into this in too detail, but I'm just trying to start building up some data for us to have a conversation. But kind of going into this, this is in the quantum chemistry fragmented embedding space, and there was a paper from Yuri cited as one of the works there that I'm sure some of you were involved in this as well. But this type of work with this offloaded quantum for portions of the calculation, so we're seeing that a couple of times. I've worked with Peter Coveney in Munich and also at Argonne now. I know that he's worked here at Oak Ridge. Some of the work that he's doing is kind of also in that same premise, large-scale simulations with offloading to quantum for particular parts of the workload to gain a more accurate result, pulling it back into the overall simulation. I believe, if I'm understanding, the work that Tom and folks here at Oak Ridge have been doing, that's also in that same sort of pattern, that same direction. So that's something that we want to look at, and that's a very nice pairing between the large-scale HPC simulations that we've already been doing, that we are very expert in doing, and to get more resolution, more clarity, more understanding of complexity from the implementation of the quantum computing. Okay, so that's that side. That's part of the story. Now, this one's a little bit messy, but this is only because I made this slide last night while I was on the plane. I was just at this Oscar PI meeting, and we had several workshops. One of them was on software, and there was a really interesting discussion. And a lot of the folks were really focused on quantum software pure, so less on the hybrid software. And because of this target, because of this blueprint, obviously it was a conversation point. The idea is that it's going to be so hard to get the technology matured into that level by 2028 to hit that peak. Let the companies, let industry go, let the individual companies who are in the running do what it is that they need to do, take whatever shortcuts and all they need to take, and just basically hit that threshold. Okay, which sure, that's completely plausible, right? On the other hand, if we've got a system that actually hits that target, what's the next question going to be, from the user community? How can I use it? How can I work with it? How is this going to, how great that you've got that result, but now I've got all this work that I want to start working on it within our community. So that becomes the natural next question. And if we have an environment set up for those power users who can hit that threshold peak, and then there's not anything behind it, we start developing that ecosystem after the fact, we're going to miss out on our user community, and we're going to have a lull space where our community is not going to be able to access and utilize this. So it makes a lot of sense to bring up and to be working on the ecosystem writ large, which is what we're doing in openQSE. And by the way, I kept really waving the flag for openQSE in this meeting because it was kind of surprising to me how many folks did not know of our efforts in this space from the more pure quantum folks in the DOE programs. So that's something that we should look at how to get more visibility. But it kind of made me think. Just kind of the conversation of Bert Young was there, and I remembered thinking about like the exascale computing project. I know several of you were involved in that as well. So for those of you that don't, this was a very large project. I want to say, where's Bob? Was it about 8 years or so? The ECP around $1 billion or so. Okay. Oh, Scott. Yeah. So, a very significant investment over several years, many people to really work on our exascale readiness in our software environment and getting those prepared for the systems that we were putting on it. And so I went back and I was reading the final update, the slides that Lori had and some other things, and just sort of reading the lessons learned. And this is something that I think would be very interesting to go back. And I started talking to Mike Haro and Lois Kaufman about this. What what we're trying to do is we're building up a lot of stuff from, from trying to understand how to bring quantum and HPC together, how to bring these components, how to make all of this work. There's a whole lot of lessons learned, and there's a whole lot of foxhole stories from the ECP crowd, from that software crew. They have a lot of bruises and nicks on them from from going through all of that. So what I really want to encourage is, I know that we're doing this in some spaces, but I think that there's actually some sort of white paper or something to really look at what we're doing now in the environment, what we can learn from ECP, how we should be thinking about this in future. And I just, and personally, I realized going through this that I missed something in the contribution to the blueprint, that we really didn't have a really concrete, articulated plan for afterwards, or even mention of needing a genuine plan afterwards for the support of this software environment and how that works. And that was one lessons learned that they had from the ECP. So there's a few others. So I guess my point is, as we're thinking about our whole ecosystem build, to remember and honor our past, and to think about that we've got a lot of brain trust in this community that would be able to help us figure out as we're going through things. Okay, the other thing that happened this week with July 22nd was the Genesis Summit, and I spent some time playing the YouTube stream of that at 2x. By the way, pro tip, turn on otter.ai, hit record, turn on YouTube at like 2x and let it go, and it gives you everything that you need. It's really amazing. I tried to get it up to like 2.5 and it was getting kind of messy, but at like 2x, it can completely transcribe everything that you need. So I was kind of like listening to it and listening to Gina at 2x, but then also reading this. And she was talking, if you were also listening to that stream, she was talking about federation, right? This is part of the American Science Cloud, the work that's being done, but about the federation aiming to shift the burden from the scientists to the infrastructure. And she talked about several different components that hit a little flag in my mind, talking about that no centralization. We're going to have systems. We're not going to have one ecosystem ruled by all, right? As we're building up all of this AI infrastructure, there's going to have to be implementations. There's not one policy. All of this is going to have to work in consortium and in synergy with each other. And this is non-trivial, right? And we'll get to this in a moment, but how that actually translates to the technical layers, this is non-trivial. And this is something that we really need to think about. We're going to have dispersed resources. Again, with quantum, we're only going to have a few systems. We're only going to have a few systems within the DOE complex. There's going to be a few systems regionally and nationally, but we're dealing with scarce resource that we also want to try to do work with. And we have to figure out how to make end-to-end workflows work with this across systems that are owned by different institutions, that are owned with different policies, administration, technical components, all of this. And this does trickle down into the design of our software and the considerations that we need to think about. So I won't go through all of this, but we have trust, identity, fundamental. We have single sign-on for as part of Genesis, but the whole trust environment for the data passing, all of these components, these things we need to think about for the quantum side, and what is delta to what is already being established within our ecosystem. And remember, this is just the DOE ecosystem, right? And what we're doing and what we're funded to do it. There's going to be delta from that, from what the regional efforts are doing of systems that we would also want to potentially access, and for the companies themselves. So we kind of have to look at this on several different layers as we go. Okay, so trying to encapsulate some of those ideas, all of that together, I kind of think about this like in 3 ecosystems. So one, we have the infrastructure ecosystem, we have a technical ecosystem, and we have a community ecosystem. And this is kind of how I try to organize myself. So I kind of talked a little bit about that infrastructure ecosystem already with the federation of the systems. We've got geography, we've got policy in mind. And the example that I want to use for that one is kind of very close to home for me. And this is just something that I'm looking at right now. We've got in the Chicago ecosystem, it's a pretty robust environment. So actually, I'll skip right here. As you might know, there's a large initiative going on in Chicago, this IQMP, Illinois Quantum Microelectronics Park, where this is going to be seeding several systems. The anchor tenant is PsiQuantum. They're building a very large facility, but there's several other companies that are going to be seeded out there. In addition, you've got the entire Chicago ecosystem from the different universities. Argonne Fermilab are out there. There are NSF hubs that are all involved. So all of these components all of these entities are dealing with quantum. They're looking to seat systems or be integrated into the services of the quantum. We've got obviously the supercomputing of Argonne. We've got definite interest for quantum HPC efforts from the industry space coming in. So there's a lot of things happening here. But again, because these are sparse resources, then how is it that you establish end-to-end workflow within these environments? What does the networking look like? But really more importantly, where's the co-locality of the systems themselves? What does the software environment look like? What does the access, allocation, scheduling, resource management, protection of idle time on the systems when you're across, different institutes. So as Gina mentioned in her talk too, that there's infrastructure and federation is a big technical question, but it's probably even a bigger policy and administration question. And these are the sort of things that when we think about the dynamicism and potentially the feedback from quantum systems back over to the HPC to the application side of HPC, these are all components and things that we need to be having in our mind or thinking about as we're going forward. Okay, and so then to the technical ecosystem. So again, this was a late night binge with my AI, but trying to think about the operations, the actual operations of the system, all the components. So not just the software environment, but all the components that go in that have to happen or be present for an end-to-end workflow, coming from the HPC side, offloading to quantum, coming back, all these different layers, all these things that have to happen. And so this chart on the left-hand side, you've got the HPC environment. On the right, you've got the quantum environment. This is already separated, by very significant cultural boundaries as well. This group is kind of a nice merging of them, but still very much in our communities, those exist in silo. And then you have to deal with the workflow orchestration between it, the scheduling components, the observability, the telemetry, the reproducibility components and assets, data management, security governance policy. All of those components have to come together in order to actually make this work. We need to think about this now because we're thinking about this. We're thinking about this for Genesis and how all this is going to work together. So what quantum is going to be, coming into it. We also have to think about it because we do want to have that end-to-end workflow that once we have the technology peaking and getting to a certain point, we are able within a reasonable amount of time, turn that around and get the user community working in that space. So this is hybrid quantum HPC, but again, we have to remember that this is not the full story with Genesis and coming in. What is AI, the AI components of all of this, how is that going to be evolving and expanding? And so that's the purple space in here and what all that's going to look like. So I hope I'm kind of building a picture in a way that there's a lot to be thinking about that will trickle into how we actually design our software environment. So to the user community. So this is a little bit of an exercise I did when I was in Munich to basically think about the different user segments, the user profiles, personas that we have utilizing our standard. So really standard mod SIM. And I had clever little names from like the clickers, the librarians, the ones, power users, bare metalheads. But from each of those, I actually assigned like somebody's name to it, a person's name. And I was really thinking and constantly asking, this sort of person, what are they doing on this system? What is it they actually need from it? What are they not getting? What workarounds are they trying to do in order to get what they need? This was a study that we did at LRZ for a while and just kind of gained some understanding of the different layers, key needs, and understandings. I've been trying to do this with the AI space. This is, Yeah, if you take a picture of this or something, please don't distribute it because I'm not sure. But basically kind of the same idea, kind of what are the buckets of the AI users? What are their actual needs? What sort of resources do they need? What sort of software services needs do they need? And how all of that works together. So now, a work that we're doing with some folks in Germany that's going to appear hopefully before too long is that we're working on quantum user personas. So kind of the same idea. Again, yesterday there was this large debate that was going back and forth, and it basically came down to no, users want this, and then like no, users want this, and then it became very, very clear. Wait a minute. Define your user. I know it's simplistic, but we are at that phase because the quantum is coming out of the physics realm. We are a lot of our users right now are what in the HPC space I'd call the bare metal heads. They're the ones that understand deeply about the qubits. They understand about the layer of the hardware in order to start executing on their results. But that next wave of users that we have to prepare for, are they going to be that way? No, and they shouldn't be, because they're not going to be able to utilize, if they're not going to be able to utilize their domain science if the barriers that they have to have that level of hardware understanding. So in any case, this is something that I would really like to look at, because as we're looking at the different workflows, especially for the workflow group, I think it's really important that we assign the users and understand what that user actually needs when they're doing that workflow, because that's going to be paramount for us really defining the right requirements to get this done. Okay, so then if I kind of start looking at them side by side by side, quantum, HPC, AI, then I start looking at it at a couple of different layers. So I started looking at it at the hardware resources layer. So what sort of partitions, what sort of file systems, what sort of, what is the simulator profile for the quantum users? What does it have to look like? This is where things like, in order for them to do their jobs, what sort of latency requirements do they have? What sort of networking? How do these components? What sort of access models? So that's kind of one area to be thinking about. And we're kind of doing that with the architecture group, I think, but that's kind of one space to look at. Another one would be the software platforms. Again, the HPC realm, we've got schedulers in the MPI. What do we have for the quantum? How are those schedulers different? How is the job being broken down, scheduled, sent out, idled? Frameworks for the AI. And then the reason I think this is also important is because, especially with Genesis, there's going to be design decisions made that could affect us for the integration of quantum. And so it's really important that we're staying very, very close, this community staying very close. And I would also advocate that in future meetings that we're constantly having updates coming from that ecosystem, from that development community, to understand what sort of design decisions are being made, what sort of things are happening in order for us to be able to align with it or react to it. Okay, services and support. Obviously, that's another big component that we need to think about in terms of what they're looking for. I'll skip that for a second. Governance and policy. So if one thing I just want to put into your mind, what happens when we have a quantum system at one institution, the HPC system at another institution, be that at two different DOE labs, regional, whatever, who's the manager, who's the worker? If you have like a quantum science center or a large instrument center for the quantum system, it's going to start evolving itself. It's probably going to have very much a manager type of allocation policy and work environment. How is it going to receive signals, or how is it going to receive jobs from the HPC that might be, another state away, or, on the other side of the country, et cetera? What is that going to look like? How is that going to work out? And does that affect our scheduling of the systems? So the folks working on the scheduling, on the resource management, we're talking about systems in close proximity to one another or within the same administrative realm. But what if that's not the case? Okay, and then this was just kind of an example I was coming up with, that everything works fine, that you've got, and actually I think I saw a version of this on the slides for the architecture of the software group. But basically, you've got something that's working just fine. You've got a token system between the environments. You've got the data flow protocols. Everything is working, but then you have some sort of calibration drift on the system, and it goes and it screws up, the HPC allocation on the national lab system side, something like that. So again, we need to be thinking about the workflows, not just from the actual interactions in kind of a spherical cow space of a protected environment, but what that's actually going to look like for our ecosystem. So I think I'm ending a bit early. What time is it, Amir? Okay. Oh, all right. So I guess my biggest takeaway here on all of this is that quantum advantage, how quantum is actually going to be a usable component to all of this and all of the work that we're doing and thinking about, is going to come from the ecosystem design itself. And it's not going to come from just the qubit technology alone. It's not to disparage the amazing work that everyone is doing in the quantum hardware companies by any means. Your job is very hard. But I think it is important for us at this phase to be thinking about the ecosystem design and a lot of these parameters, the sort of users, what their needs are, what's going to happen with the locality, co-locality. We're doing this on a very, on a technical space, but then I'd also like to start thinking about like larger ecosystem models for how this would all come together. Also then leveraging what we're doing and paying attention to our HPC and AI brethren, and how we can be implementing so that we're also not siloing creating siloed solutions that's going to end up making it harder for us to integrate in the future. So integration, federation, ecosystem, these are all very nice words that we should be thinking about. So that's basically kind of the message that I wanted to get across, and I hope that's at least a little bit of thinking for some of the technical work that comes. And if you're interested in any of this is something I'm very interested in, and I'm going to continue to work on with anybody who would like to. And thank you for your time.
Any questions?
Hi, thank you for the insightful talk. Could you talk a little bit more about the policy and the sort of drive at the national labs level for user identity and sort of the single sign-on? So what's the motivation? What is the state of the art? And what are the steps for ensuring that across the federation or federated resources, one has a single entity for a user and deriving things from that on?
Okay, so for where that's been happening with Genesis, maybe Scott, is that a you question? I'm going to call a friend on single sign-on.
And I'm sorry, I was looking at something else. What was the question? Sorry.
Yeah, so if you could describe state of the art, where things are in sort of providing an identity of a user across federated systems at the national lab level and policy. Oh, yeah.
Yeah, so SARP is the person to answer that question. He is not here. I don't know. It was something that they worked out literally like last Thursday or Friday. Yeah, I mean, they came to agreement literally back. Yeah. So, I mean, it is, I don't know the details. Thomas is. Here you go.
Passing to another friend.
So as far as the, so there's a couple pieces here. The technical pieces of this are much like what you have in cloud. There's an identity document under the AMSEC effort that is defining all these, where you have effectively a service mesh and you can auth that. The real issue with the single sign-on is the policy to allow reciprocity or across labs to say, I trust you. If you trust this person at Argonne, I'll trust them at ORNL too. That's where some of the challenges have been. But as far as the identity management and the auth out to the single sign-on, those mechanisms are all there. It's the other parts of sort of making sure they get. So your question was to, yeah.
Do you mean like authentication of a person?
Sure. Yeah. So So two parts to that, and then we'll take it offline. A key piece is that DOE cares about this now. So they actually are, everybody's talking together, getting this together. So there's a concerted effort to manage that and then work through that with the lawyers and the security people and stuff like that. So anyway, I'm sorry to, but.
And I mean, I can tell you too that in the European front, like with Euro HPC, so there was, they're working on federation of the HPC and AI systems, and the quantum is then coming from that. So this is also being actively worked on in that space, as well as they've got a big integration grant to pull together all of the quantum systems, which are connected to HPC systems at the various data centers. So all of this kind of cascades down. So I'm also hoping to get some good examples from them in the future with how they're rectifying the quantum and the HPC access, together.
Can you turn to the slide where you show the quantum personas?
Yeah.
I really like this. I was, as you put that up there, I'm like trying to identify which ones do I fall in. Did this come from like user surveys, or was it from like job identification?
This came from work from a group in Germany, a couple of doctoral students, and Wolfgang Maurer, for anybody who knows him, from this. And this was interviews that they did at IEEE Quantum Week. I think there was also a survey. And now we're looking, I mean, the N was fairly low, I'm not going to, but we're looking to how that's going to expand. And so this is something that, I've talked to Amir too about if this is something that we could or should, bring into this in some sort of configuration and have this team, help drive it and help continue the work, because there's a lot more. I think there's a lot more to be done. Obviously, this was the first cut.
Definitely, and I would imagine that data over time would be really valuable.
Yeah.
So.
Yeah.
Any other questions, comments?
Thank you. Great presentation. One of the questions that for me opens up is there's a wide range of readiness across organizations to prepare for this work. What are the greatest bottlenecks you find, and what are things we should be doing to address them?
So my answer for that sort of thing is, it's going to always be this is a full contact sport, in my opinion. I've seen, like, from the early days, I'm just going to have to take the example from being in Europe. There were a couple of groups that had ideas for how things should work and how they should, implement together. And so they kind of drove the conversation, and then other entities and other efforts sprung up. And you have to constantly go back over and over again. Just because that you've covered and you've aligned a couple of groups, you have to go back and do it over and over again. So to me, this sort of effort that we have is such a high contact sport. And this goes for the institutions involved as well. It goes for basically every component. So I don't know if I'm answering your question, but for me, this becomes constantly is about communication. Any project manager knows that. I think it's even in your PMBOK. What is it, 85 or 90% of all work in a project is communications. And that's really, really true. Especially, and I think this is even more critical in our environment, because not only are we trying to get an environment set up, matured environment for technology that itself is constantly going up and is constantly developing, and we're having a paradigm shift with fault tolerant coming, which really questions what we're going to have to change, or what can we modify, what we have to throw out, what we have to do differently. We've got that dynamicism. We've got the dynamicism of the software environment coming together, the hardware itself evolving, in an ecosystem building, and a quantum ecosystem building on top of a developing and evolving HPC AI ecosystem, right? So, this, like, what does that say? The only constant is change. That's where, and the only way to deal with change is constant communication.
Oh,
Would you be able to go back to the slide with the code? I missed.
So which one? Sorry.
To scan.
Oh, sorry. This guy. Wait, hold on. That one? Okay. And like I said, this just came out. I'm assuming, to be honest, I don't know actually what the plans are. I'm sure that this will come up in a BOF or something in some future quantum conference. But if you have any comments or anything, so section 5 is kind of on this ecosystem, on the integration components. You know, it's fairly, I mean, especially this group in particular, I think if you read it, your initial response is going to be yes and, because I think a lot of it we've been covering in our community for so long that it's probably going to be fairly obvious. But if you have any other components, obviously this is something that we want to continue developing our thoughts on. So if you have any input and all, please do contact me, especially for section 5. That would be really interesting to get your feedback.
Hey Laura, I have a question. So for the data governance, do you think it is more of a policy that we would implement at the end of the day? Or would it be more like a layer that we can have in the openQSE architecture
For which part, sorry?
for data governance and security?
So that one, I mean, I honestly, I'm going to throw that back at you guys. I don't know. I don't know if that's going to be something that if there's a whole strategy for data governance, you know, with what we're already doing, and if there's anything particular with Genesis, you know, what is being developed and what's being built into, I don't know. So somebody else who's more experienced with Genesis would be able to answer that question. But whatever that is, we should be looking at that and attempting to follow it where it makes sense.
Right, because like AI kind of also evolved from some of these policies, and now we have certain layers, right? Like in the frameworks, we have control plane across, spanning across the security in softwares, in AI models as well now. So do you envision that maybe we could have something similar in quantum?
Potentially, yeah.
Okay.